Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken, University of Albany, and Seth's brother, Joel. We're here to hopefully show you how to approach studying for the SAT and also taking specific SAT math questions. A great way to study for the SAT is to sign up for Khan. Go to the SAT website and get an account and do the Khan Academy practice. You can see instructions on how to get there on our June 29th video. We are plowing through the Khan questions because these are sanctioned by the SAT. We are at the point where we are doing algebra, and we are going to plow through. We're going to do one topic a day, and we are at this one, linear relationship word problems advanced. We already did linear equation word problems. Now, what's the difference between linear equation word problems advanced and linear relationship word problems. Linear relationship word problems. What do you think? Is that interesting, Seth? What do you think? That's interesting, right? That they make a distinction between linear equation word problems and linear relationship word problems? What do you make of that?
Well, I'm not that interested in it.
Okay, so let's get going. Practice. We are doing question 1 of the advanced. We are leaving the unadvanced for you to do yourself. Because if we go over the advanced, we talk about it, that'll presumably help you do the less advanced questions. Okay, here we go. Question 1. Seth, do you see it?
Yes, I see it.
All right. Okay, and can you annotate?
Yes.
Good. Okay, let's go. Okay, it's obviously a word problem. Please read it, pause it, come back, and we'll try to do it. The gas tank in Miss Brown's car holds a total of 15 gallons at any given time, and how many gallons G will Ms. Brown have to pump into her car to fill her tank, given the fraction of the tank F already filled? Wow, you got to figure this out, don't you? This is an algebraic.
So she wants to fill the tank, given the fraction of it being already filled.
Right.
So she has to add the fraction of the tank capacity. That's the the complement of F, which is 1 minus F. So take 1 minus F, multiply it by the tank capacity, and that should be the answer.
Oh, so you're saying it's C?
Am I saying a C? Yes. 1 minus F times 15 gallons.
Right.
Which is 15 minus 15, yeah.
To fill her tank. I'm still sort of digesting it.
Yeah. So also we could say that 15F is a number of gallons that's currently in the tank.
Right.
And so the number of gallons to add to fill the tank is how much less than 15 is 15F, which is 15 minus 15F.
What is the F again?
F is the fraction already filled.
Right? The fraction.
So if there's the tank.
The fraction already filled, right.
Yeah, so here, if this is F, this would be 1.
Right.
So in this example, F is maybe about 1/3.
Yeah, right. Yeah.
And this is 1/3. There's 1/3 of a tank. There's 1/3. There's another 1/3.
Right.
There's another 1/3. Yeah. And so if the total tank capacity, the total capacity is completely filled is 15 gallons, then the amount that's here is 15 times F. So if F is 1/3, then the amount of gas in here is 3.
No, it's 5.
Yeah. All right.
It's 5. 5. 5. 5.
Yeah.
5.
Yeah. Made a
Yeah,
mistake.
it's fine. Yeah.
Well.
Oops, not that big of a mistake to erase the whole thing. What happened? Right, there
Well.
you go. There you go. There
Well.
you go. Yeah. Yeah, so this is not just a plain, this is not a y equals mx plus b. I mean, it is, in some sense, it is a y equals mx plus b problem, but it has these fraction stuff. That's a really good idea set to make a picture. Although I would have made the picture directly. I would have said this was 15, and this was 15f, and then this difference is this x, this big dot there would be what they're asking for, which is 15 minus 15f. Yeah.
Well, on the test, I would make the picture in my mind.
Right. Yeah, I probably would have.
But we're explaining it. I drew the picture because the point of this is to explain it so other people can learn.
Right. No, but there are different approaches.
It doesn't help for me. That doesn't help you, the audience, if I simply say, well, I thought about it and I found the answer.
No. But let's go over the different approaches. One approach is to do what you did, which is for a smart person to just think it through in your head. The other approach is to actually draw the picture. In some ways, whenever you have fraction problems, a good idea is to draw the picture. Really good idea, because fractions lend themselves to pictures. Because
it's a good idea. It's a good idea to draw the pictures when you practice, and then as you practice more, draw the pictures less and less.
I don't know.
And then reach the point when you do the problems, you could do it in your head. Then you do it faster because it's a time test.
True. But fraction problems are nasty. And of course,
no. Yeah, nasty is in the feelings of the beholder.
Fine. So then, I personally think
fractions are very, very sweet. They're very nice creatures.
But you also have to be careful to answer the question: how many gallons? Will she have to pump in her car? You could do the complement to that. How many gallons? I guess they already tell you how many gallons are in the tank. So you don't have to answer that. The other way to do it, what about this approach, is let's say you get confused about how to write the equation. Make up an example and do the problem without any equation at all, and then use these choices to see which one gets you the right answer. That's like a stupid brute force approach, but it's not that stupid of a way to do it, actually. You could say, I wouldn't use a third and I wouldn't use a half, and you want to use 15, so you would use a fifth. So you would do the problem, Ms. Brown have to pump the car to fill a tank, given that a fifth has already been filled. If a fifth has already been filled, then that is 3, right? So in other words, 12 is the answer. So if f is equal to a fifth, if f is equal to a fifth, boy, I'm really writing very messy, Seth's not going to like that. F is equal to a fifth, the answer is equal to 12. So let's see. C obviously works. B absolutely does not work. A absolutely does not work. And my God, D would give a negative answer. So you could also do it that way. If you don't want to feel
if you want to do that way, think of the case when the tank is empty.
Yeah, but that's dangerous.
F equals 0.
Yeah.
And you have to add 15 gallons.
That's the easiest thing,
when F equals 0, let's see, let me scribble things. When F equals 0,
I'll erase some stuff.
Then let's see, I'll draw, not erase. When f equals 0, we want a formula that gives 15. Well, so clearly this is wrong.
Yeah.
When f equals 0, 15 over f is undefined, but it's not in this problem. It's well defined. It's 15, so it's not that. When f equals 0, this gives the right answer, 15.
Right.
And when f equals 0, 15 divided by f is undefined. So simply checking it when f equals 0 leads you to the one choice that they give you.
Right. So you see, that's really not that bad of an approach, is it?
Right.
It's dangerous.
What about when f equals 1? When f equals 1, you don't want to put, you want the answer to be 0. So it's not this. It's not this. This works when f is 1. It could be this one.
Yeah, I know. Yeah.
But checking it for 1 doesn't eliminate everything.
Right. Yeah. But
So
generally, you want to stay away from 0 and 1 when you check. You want to stay away from the weird numbers 0 and 1.5. I would stay away from 1/2 in checking, but 1/2 doesn't make sense here because you get fractions. 7.5 is too hard to deal with. Anyway, you see, A would give you the right answer. A would give you, if F was 1/2, A would say 7.5, as would C. So you want to stay away from 1/2, 0, and 1 when you're doing this brute force type of method. Love fractions. Fractions you have to be careful because in a fraction problem you have to be careful what side of the fraction you're on. Do you want to know what the like in a problem? Do you want to know basically what you have to add or what you already have? Seth likes fractions. I like fractions too, particularly when you multiply them. And here you're
adding. I can add them too.
Adding's a pain. Okay, so enough done with this. Okay,
shall we barrel on to another one?
No. We have to see how they did it.
Oh.
Right? We have to see how they did it. So, let's answer it. C. Congratulations. We get the same answer as they do. Now, where do we see how to see the answer? Isn't that option? Well, anyway.
It says C is step-by-step solution.
Yeah. So let's do that. Let's hit.
Yeah.
Oh, there we go. See step-by-step. Okay, so let's see how they do.
4 steps. Wow.
4 steps. Okay, based on the equation, the fraction of the tank is already left. Okay, for example. Okay, look, they're giving examples. That's very nice.
Yeah.
Therefore, the fraction of the tank that is not filled is the difference between one. Seth, that's exactly how Seth did it.
Yeah.
Notice they're not drawing a picture.
Yeah.
To calculate G, the actual number now needed to fill, we should multiply. Wow, they did it exactly as Seth did it on his first approach. Wow, look at that. My God, wow. This is interesting. I wonder how many people did it that way. We'll never know. Okay, what do you think? You want to try another one, or you think we're done?
Sure, let's move on.
Whoa, Seth's ready to move. Okay, let's do question 2. Here we go. Question 2. Okay. It is a word problem, and please pause it and try it yourself. Go back, and we'll give it a shot. And we have to turn on annotation. Okay. Quantitative theory of money states that given M dollars in circulation in a year, the monetary velocity, this is an economics question, V, a price level P, and a real output Q, and a real output of Q dollars. The given equation is correct. An economist considers the case where the dollars in circulation are the real output. Well, I'm going to make those constant. This is a constant. Okay, wait. Considers the case with dollars in circulation. No. M is a constant. I'll circle it now. M is constant. And the real output. Okay, fine. Those are constants. Very important. Which of the following expressions is the change in monetary velocity? That's this one. So we'll put a big star on that one. As the price level increases by 1. V is equal to PQ over M. As the monetary level increases by 1,
what is the monetary? What is the monetary level? Change? No, not monetary levels. Monetary velocity.
Yeah, that's V. Yeah.
Which of these silly variables is the monetary velocity. That
V.
is v.
V. Yeah, V. V
So
is
we
what we're
want to
after.
find the change in v when p goes up by 1.
Right.
So let p go up by 1.
Right.
And how much v goes up is, it's p plus 1. This is how much p becomes.
Right.
Q over n,
That's
which
right.
equals p times q over n plus 1 times q over n. So how much it goes up is q over n. And that's that.
Right. Yeah. 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 I'm really surprised that they didn't have an answer. Uh, P times Q over M here, just to confuse everyone. Um, yeah. Right. Yeah. 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 So
Yeah.
this is very important. This is the original V, right? This is the V
That.
original before the change, and they want to know how much does it go up after you change P by 1. It goes up by, it changes by Q over N.
Yeah.
Yeah. Yeah. Yeah. Yeah. Yeah. Yeah.
Okay. My advice of an approach to this is the following. I read it, and I realized that I have no idea. I have no idea what they're talking about. And I have no idea how accurate what they're talking about is.
Yep.
And they say it's a theory.
Right.
So what that did to that led me to do was not think about what it might mean, and simply treat the 4 variables as variables. In algebra, you're told that 2 of them are constant, and you're given an equation, and based on the given equation only to solve the problem, and not think of these things, not even think of what money, velocity, price, real output, what those mean.
Right. Absolutely. That's completely correct. Yeah, you just treat it as an equation.
Whereas in word problems, or problems translated with words in algebra, where the situation does make sense to you, then take advantage of the sense you have in it. Like the previous problem,
right,
was about filling a gas tank, and the situation was one that people are familiar with, and which, in terms of quantities of things and fractions of things, fillingness and emptiness is something that is pretty obvious and makes sense.
Yeah, it's intuitive. It's intuitive.
It's intuitive.
Yeah. The more intuitive a question is, or the more intuitive you make a question be to you, the more likely it is you're going to understand it and you're going to do it right.
Yeah. However, it's this indicates that in doing math and applying math, we sometimes apply the math to situations that don't come with any intuition.
Right.
Now that is useful in order to say make a guess, a hypothesis, and express the guess as a formula, and then do the math to figure out consequences of the formula.
Right.
And then we compare the consequences with reality in order to judge, how well does the theory expressed by the formula explain reality.
Yeah, but I mean, yeah.
But this problem has none of the information to begin none of the information that would lead lead you to begin that kind of analysis.
Right. So then, well, I have I have another thought about that. Let's move. Fine, I think we should be done with what you just said because it doesn't have to do with solving the problem. It's interesting. Most of these problems, when you have something held constant, are usually like the gas laws in chemistry, where the volume goes up twice. How much does the pressure go up? It's more of a multiple thing. This is a different problem because here something's increasing by one. Usually these things are how much does it go up if the velocity increases by a factor of 3. That's usually how this problem is asked.
Well, it depends. It could be one way or the other way. You could compare changes in 2 ways.
Right.
You could express a change as a difference.
Right.
Is one way, and the other is to express a change as a fraction.
Yeah, as a multiple. As
a division.
Right. That's right. But usually, I'm just saying something. I know you hate when I generalize, but usually problems like these are usually given by factors. If you double the thing or you triple the thing, how much does?
What's the usual? I don't know.
I know you hate when I say that. But
I hate when you say
it. I know
yes.
you hate when I say that.
Have you done the statistics?
No, absolutely not. I'm totally.
So you're just talking through your hat.
I am just talking through my hat. Absolutely right.
See, you're not even wearing a hat. You should get a hat.
But I'm talking with a little bit of maybe intuition. But I'm just making general observations. But this is a different problem because here you have to add.
You're making a general ideology.
Okay, fine, let it go.
A general ideological statement.
Okay.
With no evidence.
Give it up. Yes, it's true. I admit guilty. But you have to be careful about this problem because it's a little bit different from what most people, I think, the problem that's used to given. The other thing I want to ask is, what do you think of this compared to the old? This is the digital side of practicing for the post 2024. After winter 2024. How do you think this problem compares to the other problems we've done? We've been doing this for almost a year. Do you think it's a little harder?
I think this is being more abstract. It's more abstract.
Yes.
Than other problems we see.
Yes. I think that maybe
so that makes it a bit harder.
Yeah, I think that the new SAT, the digital SAT, is more into heavy concepts. Really understanding the concepts as to what's going on. And I think this is an example of that. This is a little bit harder than one of the harder side problems we've done.
Yeah.
So be aware of that when you're getting ready for the SAT.
So let's pick our answer and see.
Oh yes, let's pick our answer.
How their explanation compares with ours.
So ours is Q over M. This is really a fascinating problem because you have to do that 1 plus P. And wow, this is a tough problem. Okay, let us clear the annotation. Clear everyone. Okay, we're ready to go. Okay. Or see how we answered this question. Interesting how we didn't get that last time. I don't understand computers. Maybe Seth can explain them to us. Okay, why in the first question we didn't get that choice, now we do. Okay, anyway, shut up, Joel. Because we're looking for a change in V with respect to a 1 unit increase in P, we're looking for the slope of V with respect to P. Woo! We should rearrange the equation so that V is the dependent variable. So we did that. We move M to the other side. Okay, fine. So we get that. We did that. The slope of V with respect to P is the coefficient of P, Q over M. The monitoring velocity, Q over M, changes by Q over M for every 1 unit increase in price level. Wow, so they took another approach. Good for them. This is good. So you can see there's more. Obviously, there's always more than one way. There's usually more than one way to do a problem. It's not a bad way to do it. This is even more abstract than the way we did it. This is like super abstract. So that's something to be aware of, is start to think a little more abstractly when you're studying for the digital SAT.
Yeah.
Yeah. What do you think?
Oh, yeah. No, I think he does,
Seth?
but
well, yeah, they made it more. They recognize that the relation between P and V is linear.
Right.
But what would have happened if the relation between V and P was reciprocal? In other words, V equal the constant times 1 over P.
Well, first of all, that's
if
not
P
linear.
increases by 1, we can't talk about, we don't have the function of V is a function of P when it has the form constant divided by P. The curve of that does not have a constant slope.
Well, first of all, just to be devil's advocate, the topic of the day is linear relationship word problems, not nonlinear. Linear,
yeah.
Right?
So they purposely it's a linear problem because this part of the curriculum is on linear problems.
Yes, but there's
so
also
they gave us a linear problem.
Right. But one, you don't know that when you're looking at the question. But two, they also have nonlinear problems, which we'll be getting to. Those are also part of the curriculum.
Okay.
So when we get there, maybe they'll have that question.
All right. Well, do they give a step-by-step explanation?
For what?
Oh, that's it. Yeah, that's the step. Yeah, okay.
Yeah. So what are they saying? They're saying that this is the relationship, right?
Yeah.
Between, hold on a second. This is P. This is M. And then you go up by 1. This is the slope, right? The slope is Q over M. So if you go up by 1 here, then you go up by Q over M here. They will use a fancy notation, delta M. Delta M, and delta means change of. It's like a Greek.
Well, I think the vertical axis should be labeled V.
Wait, that can't be Q over M.
The vertical axis, you labeled it M, it should be V.
Yeah, that's why something was seriously wrong. Right, okay.
Yes.
Yeah, that was why when I was looking at this, I was saying, wait, there's a problem here. Yeah. So the change in V.
No, you look at the V. V is our linear function of P.
Right, yeah. So now we're showing different ways to think about it.
Yeah.
When I was looking at this, you probably see in my eyes, I was getting confused myself. I said, something's wrong. Yeah. So anyway, that's a good way to do it. Very, very conceptual, though. Very abstract. Okay, so I guess that's it for today. Please like us, dislike us, give us comments on our YouTube videos. And if you have any SAT math questions, please email us at satmathquestionoftheday@gmail.com. And tomorrow we'll plow through the next section in Con, and we'll just go through all the questions. Okay, everyone. In the meantime, if you're going to take the digital SAT, you should sign up with the SAT and start the practice yourself. Okay, everyone. Have a great day. Bye.